The correlation coefficient measures the linear association between two continuous variables. How do you know if things are linear? You have to look at the data. If the data aren't linear, you can't use a correlation. But remember, we talked before that perhaps we can transform our data to make things meet the assumptions of a test. It feels like cheating, but it's not. I'm going to show you some really cool data. These are older data, but they teach us a lesson that sometimes a transformation can reveal the true pattern in the data. These are data from 2003, and they were investigating the relationship between campaign contributions by defense contractors and then the amount of work that the companies were awarded for reconstruction projects in Iraq and Afghanistan. There was a rumor that there was some sort of relationship that the more money you donated to politicians, the more likely you were to be rewarded projects. Now, that's not good. That's called bribery. Now, there was an analysis, and they looked at the data in 2003. This is Slate magazine. A magazine, it's kind of like a book, but the pictures are really glossy, and there's a lot of advertisements in it. In this magazine's analysis, they said the correlation is 0.19. It's significant. It's positive, but it's not significant. 0.19. And when you looked at the data, here are the data. Here's our 0.19, and we're looking to see if there's a correlation between the amount of campaign contribution and the size of the reconstruction contract. But think about how the correlation coefficient works. We take the X variable and we say, how far are the points from the mean of X? How do they vary with respect to X? And for a given point, how far is it from the mean of Y? How does it vary with respect to Y? How do these things vary together, the covariance? And if you look at these data, I think we would say the mean doesn't really make sense. It's skewed. We have a bunch of small campaign contributions and then a couple big ones. We have a bunch of small reconstruction contracts and then some big ones. Is there a way to transform the data, to put it on a different scale to see if there's actually a relationship or not? Yeah, and the answer is death. No, the answer is logarithms. If we log the data, the log of the campaign contribution, the log of the reconstruction contract, look at what the data look like. You have all these little small ones here, and then you see the actual relationship now becomes linear. And I'll draw a line through this stuff all day, twice on Sundays. There's a relationship here. The more you donate, the more you get. And that correlation is 0.60. So always look at your data. Always look at your data. Think about the assumptions of the test. Think about the mechanics of the test. And make sure that the analysis is appropriate for the data. Don't mistake the map for the territory.